So welcome to this video. This video, maths tuition video, is aiming to answer a question that we're frequently asked in terms of when we're trying to achieve those highest grades, grade 7, grade 8, grade 9. Quite often we are asked, what is it that actually gets you a grade 9? And I suppose pupils are expecting us to list a series of topics, which of course there are. There are those higher level topics that students do need to be absolutely confident and capable of answering. But it's not just topics themselves. We believe that actually there's a greater level of thought, a greater level of thinking skills that are required. So what this video aims to do is just go through some of those thinking skills that we've identified as being needed to achieve the very highest grades before we then move on to looking at, like we've already stated, some more topic specific videos. So you can see the 5 bullet points we've identified is all about interpreting unfamiliar problems, of course, selecting the correct method to solve a problem, show all your reasoning, working out clearly, avoid those common mistakes, and certainly when it comes to questions on the topic of proof, just make sure that you're showing enough mathematical justification. Now, to address each of those 5 bullet points, we've prepared a series of questions. I think we have 10 or 11 questions, and we're going to not only address the bullet points, but we're going to systematically show how the grade level of difficulty also changes when, like I say, addressing these thinking skills that we've identified. If you are a pupil that is really aiming to achieve the very highest grade. So if we look at the first set of 4 questions, these 4 questions, grade 7 onwards, and mathematical fluency. So if we start then with the first question. The first question, a rectangle has length x plus 5 centimetres and width x minus 2 centimetres. Write an expression for its area. So I always like, if I can, just to begin with a very simple diagram when relevant. And we're told x plus 5, and we're told x minus 2. It doesn't really matter which way around you get these measurements. But we should know, really, from primary school, certainly year 7, that in order to work out the area of a rectangle, we're looking at length multiplied by width, which in this case would give us x plus 5 multiplied by x minus 2. If you expand these brackets, and there's a whole host of methods that you might be familiar with, some of you might use the acronym FOIL, some of you might use the grid method, but essentially we're just multiplying together a double bracket, and we will get x squared plus 5x minus 2x minus 10, and we must always remember to simplify our quadratic expression if we can. X squared plus 3x minus 10. And there is the expression for the area of that rectangle. If we look at question 2, it still involves brackets actually, and this fluency when we're manipulating algebraic expressions. Here we're not actually looking for an answer in the numeric sense, but we're identifying one of those common mistakes, common misconception that pupils do make. And it does apply to the most able students as well. When we're finding a question perhaps that we think is easy, we can be prone to rushing and making that careless error. So if we take the question, when we expand brackets, we must multiply each term in the bracket. Now we can see here 3 times 2x gives us 6x. However, has the student expanded the bracket correctly? In other words, has the student multiplied by the second term inside the bracket? I would say not, because 3 times 5 is 15. So explaining the mistake, I would simply write the student has not multiplied by the second term in the bracket. Just takes me a little moment here. I would actually include the correct answer as well. So I would write 6x plus 15. Now, at this stage, you might be thinking, I'm pretty confident with what he's going through, what Liam's going through. Remember, you can fast forward the video. You can start looking at the more challenging work already. But I do like to have that clarity and take that step-by-step approach so that we can build confidence as we go. So question 3, a number is increased by 15%, it becomes 92. Lots of ways of answering this question. Personally, I'm going to look at the multiplier method. If I want to increase a number, let's just say the number is x, you can choose any letter variable that you like. I'm just choosing x. It's increased by 15%. So the multiplier to increase by 15% is 1.15. We know the answer is 92. I'm trying to find x, this original number. So we'll have x equals, what's the inverse of times 1.15? Well, it's divided by 1.15. Therefore, x equals, and we can use a calculator. At this stage, we're just trying to build that confidence, confidence, clarity, and resilience. 92 divided by 1.15. It's quite a straightforward calculation, and we get 80. Question 4, yet again, it's another question where there is more than one way of answering it. A bag contains red and blue counters. The probability of choosing a red counter is 3/8. There are 40 counters in total. How many blue counters are there? Well, we could work out how many red counters there are, subtract that away from 40, gives us our blue, or we could look at the problem at source. If 3/8 are red, 5/8 must be blue. So I'm simply going to find 5/8 of 40. 40 divided by 8 gives us 5. So in other words, 1/8 of the counters is 5, but we need to know what 5/8 are. 5 times 5 gives us 25 blue counters. Now the next set of questions, we believe, move on from grade 7 and they start to broach the applications you'd expect from pupils if they're achieving a grade 8 or those sorts of topics. So question 5. 5, 9, 15, 23, 33. Find the next two terms in the sequence. Well, straight away, we should be familiar with writing down the difference between terms. And that's from the topics such as nth term, linear sequences. Now, straight away, we can see this isn't a linear sequence because the difference isn't consistent. There isn't a constant difference. But in actual fact, the difference is merely increasing by 2. So the next difference would be 12. That would give us 45. And the next difference would be 14. So our next two terms are 45 and 59. Explain how you know. The difference between each term is increasing by 2 each time. Hopefully that's pretty straightforward. But at the start we said about including enough mathematical justification. Please don't just simply write the answers 45 and 59. It'd be quite clear to anyone you know what to do, but it is actually asking you to explain how you know, not just writing the answers. Okay, the next question. The perimeter of a rectangle is, well, for a start, I'm going to start by drawing a rectangle again. The perimeter of a rectangle is 54 centimeters. The length is 3 more than twice the width. So let's call this value here x. 3 more than twice the width. To work out the perimeter, we know it's the sum of all 4 sides. So I'm going to write it out the long-winded way. 2x plus 3 plus x plus 2x plus 3 plus x equals 54. Now, if we collect our like terms and simplify the expression, in actual fact, we have 6x add 6 equals 54. And we are now looking to solve a two-step equation. So the inverse of plus 6 is to subtract 6, and we must balance that equation. Again, this should be a topic really quite familiar with you from your prior knowledge, your previous learning. 6x equals 48, x equals 8. But don't forget to substitute back in. X is 8, 2x add 3, 2 times 8 is 16, 16 add 3 is 19 centimetres. And we should also fill in our units. To make my answer super clear, I'm just going to write it in the answer space here provided. So let's have a look at questions 7 and 8. We're still on the grade 8 topics. A shop reduces the price of a jacket by 20%. The sale price is 48%. The following week, the price increases by 20%. A student says the jacket will now cost £60 because the percentage change is cancelled. Is the student correct? Well, let's simply do it. 10% will equal £4.80. Therefore, 20% will equal £9.60. 48 add 960 though equals £57.60. Is the student correct? No, the student is not. Correct. Explain your answer. 20% of 60 is larger than 20% of 48. Again, making sure we explain the answer. Question 8, a right angle triangle. Well, once again, I like to draw a problem if I can Really helps with my visualization, just so I can see what's going on. So we have our right angled triangle. Just to be really precise, I'm going to mark that right angled triangle, right angled on in my triangle. Has sides 7 centimeters and 24 centimeters. So I've not chosen a very clever scale here, but it is just a sketch, and we're being asked to find the length of the hypotenuse. So as soon as I've got a right angled triangle, two topics really do spring to mind: that of trigonometry and that of Pythagoras' theorem. In this problem, we only have lengths, so it's a Pythagoras' theorem problem. C squared equals A squared plus B squared. C squared equals 49. Now, here it's probably worthwhile me just making sure that I label my triangle A, C, and B. I'm probably taking that a little bit for granted. 24 squared, take every opportunity you can to make sure that you can use your calculator properly. This, it would be on a more likely than not, it would be on a calculator paper. They all work slightly differently. Don't get any bonus marks for doing things in your head. 576. We add the 49. We get 625. We then must work out the square root of 625. And again, take every opportunity you can just to practice using your calculator. I know some of you will be tempted to do that in your head. It's quite a straightforward square root, but we get 25 centimeters. So a little bit of recap there on Pythagoras' theorem. We'll now look at questions 9 and 10, and you'll now see we're moving on to what we are referring to as grade 9 reasoning, and actually proof. It's a topic that pupils do find more challenging naturally because there quite often isn't a numerical answer. But we'll have a go. A sequence is defined by n squared add n, where n is a positive integer. A student claims every term in this sequence is even. Prove whether the student is correct. Key word here, prove. So you can't just start using a lot of numbers and showing it. We're trying to prove it algebraically. Now, the first thing I'm going to do, and I suppose it's experience that tells me this, is I'm going to factorize that initial expression. And that gives me n multiplied by n plus 1. Well, n multiplied by n plus 1, that'll be multiplying two consecutive numbers. And that's really important to get our head around in the first instance, because that will mean we're either going to be, if you're multiplying two consecutive numbers, it means we're either going to be multiplying an even times an odd, which equals an even, or we're going to be multiplying an odd by an even, which is also an even. The reason being, if you multiply by an even number, you're multiplying by a multiple of 2. Hence, the answer will be a multiple of 2. But let me take it that one stage further. Think back to the first slide. Enough mathematical justification. So let's just start off by saying n is even. In other words, we're doing even multiplied by an odd. I'm just going to say then, for our even number, n equals 2k. So therefore, we'll get 2k multiplied by 2k plus 1. And that's just by substituting 2k in for n in that initial expression. That will give me 4k squared, add 2k. How do we demonstrate a number is even? It must be a factor of 2. Well, quite simply, we can factorise to get 2 open bracket 2k squared plus k. So we've demonstrated there, if n is an even number, n times n plus 1 is also even. So let's just assume that n is an odd number. In other words, we're going to do an odd times an even. So this time we're going to say n equals 2k plus 1. And again, I'm going to substitute in to my initial expression. So this time I'll have 2k plus 1, open bracket, 2k plus 1, and I've still got the plus 1 on the end. Close bracket. So that will give me 2k plus 1 multiplied by 2k plus 2. I put this first expression in brackets. Multiplying a double bracket will give me 4k squared plus 4k plus 2k plus 2, which simplifies to 4k squared, add 6k, add 2. But remember, how do we know if a number is an even number? It has to be a multiple of 2. And once again, with some very simple factorising, we get 2 open bracket, 2k squared plus 3k plus 1. And there's your mathematical justification. So lastly, we'll look at question 10. 2 students solve the equation 2 open brackets x plus 3 close brackets equals 14. Student A writes 2x plus 3 equals 14. Student B writes x plus 3 equals 7. Both continue to solve the problem. Which student has used a correct method? Explain fully. Very similar to I think it was the first, perhaps second question. When we expand brackets, we must multiply out each term. 2 times x is 2x. 2 times 3 is 6. So straight away, we know student A is wrong. But student B hasn't written 2x plus 6 either. What student B has done, if I do student B's response in red, they've divided each side through by the common factor. In other words, they've divided each side by 2. 14 divided by 2 is 7. Dividing by 2 is the inverse of multiplying by 2. So, which students has used the correct method? Make sure we answer the question. Student B has used the correct method. Explain fully. Student A only expanded by the first term in the bracket. Like so. Student B divided by the common factor of 2. So these questions, these 10 questions, we're not hitting a specific topic. Remember, the question I'm trying to answer is, we often get asked, what actually gets you a grade 9? And yes, there are topics, but it's a different way of thinking as well. And that's what this video is aiming at. for those pupils aiming to get the very best or very highest grade. Now, I'd like to finish off by a question that we're referring to as a grade 9 challenge question. It's an Olympiad style question. So I'm just going to begin by reading it out. I always do. I like to read the question out loud whenever possible. I know you can't in an exam, but we need to get used to listening and understanding the question. So a two-digit number is written as 10a plus b, where a and b are positive integers. The number is reversed to give 10b plus a. The difference between the two numbers is 36. The product of the two digits is 21. Find the original number. I'm just going to begin by doing what it says, the difference between the two numbers. So 10a plus b, difference being a subtract. Just to be super clear, I'll put each expression in brackets. Minus 10b plus a equals 36. 10a subtract a will give me 9a. b subtract 10b minus 9b equals 36. And again, I think I can factorise. I like to factorise when I can, because what factorising does, it enables me to divide each side, keep numbers relatively small. So the first thing I've worked out is these two digits, A and B, they have a difference of 4. So straight away I'm thinking, could be 5 and 1, could be 6 and 2, could be 7 and 3. You get the idea, 8 and 4, 9 and 5. But as well as that, we're told the product of the two digits, bearing in mind they're whole numbers, we're also told, if I do the second part in a different colour, we're also told A times B is 21. So we need two whole numbers, because that's the definition of an integer. In fact, we need two positive whole numbers that have a difference of 4, that have a product of 21. Whilst you can solve this mathematically, I think it's pretty clear to see 7 subtract 3 is 4. 7 multiplied by 3 equals 21. So our two numbers would be 73 and 37. If you do want to double check, do they have a difference of 36? Well, 73 subtract 37 does indeed equal 36. So our original two-digit number is 73. Please don't forget to tune in to the next two videos, which again, we're not addressing specific topics. We're just looking at the background to some of the questions we frequently answer for those pupils aiming to get the very highest grades. Thank you once again for watching.